Hi everyone, and welcome to my session, Analyze Your Data with Window Functions. My name is Lior King, and I'm a Senior Instructor and Solutions Engineer at Couchbase. So what are we going to talk about? We'll understand what window functions are and why they're actually needed. We'll explore the window functions that Couchbase offers and learn what they can do for you. We'll also see how window frames can be used for more advanced uses of window functions. The session will include many examples, demos, and some fun with a dataset of movies. So before we get started, here's what I assume you already know. You should have some prior experience with the Nickel language, and you should be familiar with the JSON format. And that's all. So let's get started. Our dataset across this session will be a movies dataset from IMDb. We will use the movie's title, release date, revenue, vote average, and genres. If you are interested in this dataset, please leave me a message on the chat of this session. So what are window functions? Window functions were created to solve a very common problem. How can you show aggregated information alongside non-aggregated information? When you use aggregation, you need to use the group by clause, but that will aggregate your entire result set and you will not be able to show the original data set. So a common trick is to use another query that calculates the aggregation and then join it with the document set that you have. Let's see an example. I want to display all the movies, and next to each movie, I want to display the average vote given by the public for the movies of the same release year, the year that the movie was released. Suppose I use the well-known trick of using another query that calculates the aggregation and join it with the document set. I will get something that looks pretty much like this. As you can see, I joined the movie document set with a query that calculates for each year the average vote. And then I join these two together by equalizing their release dates. Let's see how the output looks like. So we copy this query here and execute it. And you can notice the year average column that gives you the average vote of all the movies of year 2017. Let's look at the execution plan. And you'll notice that there are two index scans here and a join that joins them together to get you the result. So what are window functions? Window functions allow you to get aggregated results without actually making the result set aggregated. Window functions do not cause documents to become grouped into a single output document like non-window aggregate functions would. Window functions are calculated as a final step before the document set is projected to the client. So when would you consider using window functions? When you need to perform a calculation across a set of documents that are somehow related to the current document. Let's see how it is being done. A simple window function will look pretty much like this. There's the function name and then the over clause with the word over and a window definition in parentheses. The window clause defines the set of rows that the current row is related to. That set is called a window. The function can be an aggregation function like sum, count, average, etc., or a special function that can be only used with the over clause. We'll start with aggregation functions that you are probably familiar with. The following query is doing the same thing as the previous query we've executed. It displays all the movies, and next to each movie, it displays the average rating of the movies from the same release year. Let's analyze what this query is doing and understand its syntax. There is an aggregation function, avg, average, and then the over clause. In the parentheses, we have a special clause, partition by. The partition by clause specifies how to create windows or how to group the data together for the calculation. But notice there is no group by clause for the query. So what the function indicates is that an average calculation would be performed on each year of the release date field, and it would be presented next to each row in the result set. Let's execute this query.
So we copy the query and we execute it. And let's move to tabular format. And you're going to see that the year average is the same as before for year 2017. Let's take a look at the execution plan. And you will notice the new window aggregate phase. And it comes right after the filtering and the order by, just before the projection.
Now, let's compare this query with the former query that did not use window functions. It's pretty obvious which query is more simple and more elegant. Let's compare the execution plans of these two queries. The window function is executed after the whole chain of execution completes its work: the index scan, the filtering, and the ordering. It is the final step before the projection of the results to the client. Notice that there are no joins or something like that, and there's only one index scan. Whereas when we inspect the statement that we executed before, that didn't use the window function, it looks quite different. Here there are two index scans, one for getting the documents and another that calculates the average vote for each and every year. And there is a join process that joins these two together. So no wonder why window functions are a lot more performant. With window functions, you can call all the aggregation functions that you are familiar with, like count, sum, min, max, average, etc. Here is an example of using multiple aggregation functions in one statement, which calculate for each movie a set of functions that aggregate the data for that release year. Again, notice that there is no group by clause here. As you can notice, window functions are not only very performant, but also generate a simple and elegant code. Let's execute this query.
So we copy the query and we execute it. Switching to table mode. And as you can see, we get all the aggregations that we asked for. We see the year AVG, which is the average vote for all the movies of year 2017. We see the year count, which gives you the number of movies that have been shot in 2017. Well, at least in this data set. We get the maximum vote for all the movies of year 2017, which is 10. And we get the year minimum vote and also the year sum, which is the sum of all the ratings of all the movies of year 2017. Let's look at the execution plan. And you're going to see the window aggregate phase right after the filtering and the ordering and before the projection.
Let's take a look at another example. Here, we'd like to get all the movies, and for each movie, we'd like to present the average vote for movies of the same main genre, as well as the average vote for all the movies of the same release year as that movie. With our window functions, we need to calculate the average vote for movies by release year and the average vote for all movies by the leading genre. Notice the two different queries we've just created, and notice the left outer join we are casting to glue these two together into one result set. Let's run that query.
So we copy the query and we execute it. Well, it takes a while. And now we switch to table mode, and it took 3.3 seconds to run the query, and the results are the same. Let's take a look at the execution plan. Notice that we've got 3 different index scans here. And we also have 2 joins to join the whole thing together. So this is not a super performing query, right?
Now let's take a look at the same query with window functions. In the first window function, we calculate the average vote by release year. In the second window function, we calculate the average vote for every leading genre. No group by, again, is required. Let's compare it with a former query. Notice how simple this query becomes. Window functions have been introduced in Couchbase 6.5 and are available for the Enterprise Edition only. Window functions are supported by both the query service and the analytics service. Like every nickel query that is executed by the query service, you need to make sure you have the right indexes, whether they are covering or non-covering indexes. The window functions of Couchbase support all the aggregation functions that Couchbase offers, like sum, average, count, etc. In addition, there are non-aggregating functions that are special for window functions and only work with window functions. These functions are row number, rank, dense rank, NTILE, first value, nth value, last value, lag, lead, comb distinct, percent rank, and ratio to report. Let's examine these functions. The first special window function I'd like to talk about is the rank function. The rank function returns the position of a row within the window defined. Here is an example of the rank function. The window definition partitions the result set by the release year of the movies, so every year is calculated separately. But notice also the order definition. The order by specifies the order of the field within the window. The rank function uses that order clause to define the ranking of the movies. Since here we are ordering in descending order, the rank function will give the rank 1 to the highest vote, and the rank 2 to the second highest, and so on. The highest ranking will go to the lowest vote. And since we partition the data by year, then every year is ranked separately. The result is that we will get a rank for each movie that is defined by the average vote within the release year. Let's see how that looks like using the query workbench.
So we copy the query, we execute it, switching to table mode, and we can see here the year rank. So all the movies that got the rating 10 are ranked first. They have the ranking 1. The movie with 9.4 for its rating is in the 6th place. We see that all the movies that have the rating 8.7 are ranked 10th. And that's the idea behind the rank function.
Couchbase offers 3 ranking functions. All of them rank the data by the field specified in the order by clause inside the over clause. The row number function generates a sequence number for each document which follows the sorting specified by the order by clause. We've already encountered the rank function, which ranks every document. If 2 or more documents have the same ordered value, which in this case is the vote, notice line 2, 3, and 4, then rank produces the same rank for all of them and continues with row number when the vote changes, like here in line 5. Dense rank does the same, but when there are lines with the same vote, it continues from the last rank plus 1, like here in line number 5. The row number function doesn't care if the votes are the same or not. It will always run sequentially. Let's see an example of using all these functions together. Here we call all these functions together, and for all of them, we partition the data by their release year and order by the vote in a descending order. That means that the movies with the higher votes will be first. Let's run this query using the query workbench.
So we copy the query and we execute it. Switch to table mode. And here we can see all the ranks. We see the year rank, we see the year dance rank, and also the row number, which always produces a simple sequence number.
When using the query engine, you always need to make sure you've got the right indexes in place to support your query. But window functions can be executed by the analytics engine as well, which offers very good performance even if you don't have the right indexes in place. Let's stream the movies documents into Couchbase Analytics and then test our query using the Analytics workbench.
So now we go to Analytics and we create a dataset called Movies on the bucket Movies of all the documents of type Movie. Now we need to connect the data service with the analytics service. So we issue the command connect link local. And that's it. We now need to wait for all the documents to get streamed into the analytics service, and we can start using it. Let's run our query against the analytics service. Notice that we are not querying anymore from the bucket movies, but from the dataset movies. Let's see the results. Amazing. That's the same result, and we got it in 600 milliseconds, and we didn't create any index whatsoever.
Another interesting window function is the NTILE function. NTILE gets a number as a parameter, let's call it n, and divides the result set in each window into n equally sized groups and gives each and every group a sequential number. NTILE is based on the order by clause, which defines the order by which the movies are sorted. In this example, NTILE divides the movie set in each release year into 10 equally sized groups and numbers each and every group by the vote in a descending order, because that's what's specified in the order by clause. So group number 1 contains the movies with the highest scores, and group number 10 will contain the movies with the lowest scores. Let's execute this statement using the analytics workbench.
So we copy the statement and we execute it. Notice the year group column here, which is the alias for the NTILE function. We've executed NTILE with a parameter 10, so it divides our data into 10 groups, 10 even groups. So the first 4 documents are in group 1, then the next 4 documents are in group 2, etc.
Let's see some more window functions that Couchbase offers. The lag and lead functions enable you to copy a value of a field from a preceding document in the list or from a following document in the list. The beauty of these functions is that you don't need to issue a correlated query to get a value from a preceding document or from a following document. The function can go forward or backward and can calculate that for you without joining any sets. Let's see how it works on the analytics engine.
So we copy the query and we execute it. Let's see the results. So we can see here how lag revenue gives you the revenue from the former line. Lag revenue, comma 2 gives you a value from 2 lines back. Lead revenue gives you the value from the next line. And lead revenue, comma 2 gives you the value from 2 lines ahead. So you can see how you copy values between different lines.
Another group of window functions that Couchbase offers are the relative functions. The first value function gets the first value of the window. The last value function gets the last value of the window. And the nth value function gets a parameter n and returns the nth value of that window. So if n equals 2, then it will return the second value. If n equals to 3, then it will be the third value, and so on and so forth. Let's see an example. This query presents for each movie the most profitable movie in its release year. So we partition again by the release year, and let's run this query in the analytics workbench.
So we copy the query and we execute it. And let's see the results. So here you see that the top movie for year 2017, the movie that made the highest revenue, is Beauty and the Beast. And we use that value throughout all the rows because we are using the first value function. And that's going to be the same for year 2016, in which we will see the top movie for that year.
Other window functions that are available by Couchbase are cumdist, percent rank, and ratio to report. These functions return statistic distribution metrics that are related to the selected window. Because of time constraints, we will not cover these functions in this session. So window functions work on a window of documents defined by the partition by clause. Now that you understand how window functions work, let's take these window functions to the next level with window frames. Window frames enable you to divide the partitions into smaller subsets. These subsets or frames differ from row to row. To explain how that works, let's examine the document set of the movies on the left here. We partition the movies by their release year. Notice the different colors for each and every year. Let's examine the first partition, year 2017. For the first movie, we can select all the movies from that first movie and downwards in the list. For the second movie, we can select all the movies from that second movie and downwards in the list, again, within the 2017 year. Now there are two movies here, right? For the third movie, we can select all the movies from that third movie and downwards in the list. But there is only one movie. So the move function can be activated on a specific frame in the partition as you define. To define a window frame, we can add inside of the parentheses of the over clause a special syntax that determines the framing mode and the framing boundaries. The mode can be one of the following: rows, groups, or range. In addition, you can optionally specify parts of the window frame that you might want to exclude from the frame. It is important to specify that you need to use the order by clause inside your over clause, because that determines the order and the framing that will be selected for each and every row. So let's explore the different modes of the frames and see some examples. The first mode we'll explore is the rows mode. The rows mode instructs the database to treat each input row separately as individual entities. Couchbase iterates over all the documents of the set, document by document. When you specify the rows mode and set the boundaries to between unbounded preceding and current row, Couchbase starts iterating over each document and gathers all the documents preceding to the document within the same partition. The current row is included as well. When the current row is the first row, the frame will contain only that row. When the current row is the next row, the second row, the frame will contain the first and the second documents. When the current row is the third row, the frame will contain the first, the second, and the third documents, all within the current partition. So if the current row is row number 4, and I'd like to calculate the sum of all the documents in the frame, I can use the sum function over that frame, for example. Another example is the frame rows between unbounded preceding and unbounded following. The frame is static and refers to all the documents of the current partition, regardless of the location of the current row. You can also specify the location of rows relative to the current row. When you specify rows between one preceding and one following, you refer to a frame of 3 rows where the current row is in the middle. When you specify rows between 3 preceding and 1 preceding, you refer to a frame of 3 rows that came before the current row. So let's see an example of using frames. We'd like to display all the movies and the revenues partitioned by the release year and ordered by the rating, from the high score to the lowest score. And next to each movie, we'd like to display the accumulated revenue of all other preceding movies in the list. So we use the sum function to sum all the preceding movies, and we define the frame with rows between unbounded preceding and current row. That way, the sum function will be activated on all the values in the frame per each document. Let's execute this query using the analytics workbench.
So we execute the query. Let's see the results. So as you can notice, the accumulated revenue of line 2 is the sum of the revenues from lines 1 and 2. The accumulated revenue of line 3 is the sum of the revenues from lines 1, 2, and 3, and so on. So this is how you can accumulate values from previous fields of your dataset.
If I wanted to write the same query without window functions, I would probably need to perform a calculation of the aggregated sum for every document using a select statement. Notice the inner select statement here within the outer select clause. That will force Couchbase to perform the inner select for each and every document. So suppose you have 40,000 movies. That means that you'll run the inner query 40,000 times. And that will take a long time, right? To demonstrate that, I'm using a common table expression that limits the number of documents to 1,000. Otherwise, this query will run like forever. Let's take a look at another example. The following query here finds the average rating of all movies that are better than the current displayed movie and are from the same release year. Notice the frame condition here, marked in red, rows between unbounded preceding and one preceding. Everything that comes before the current row. Let's execute this query on the analytics workbench.
So we execute the query. As you can notice, every value on the AVG of better, which is the first column, is an average of all its preceding items in the vote average column here.
Let's take another example. We'd like to present for each release year how many movies have been released and what year is the 6th place in terms of the number of movies released that year, compared to the other years, of course. Notice that in this case, we need to aggregate the data with an aggregation function first, and we use the group by clause. That is because we want to get one line per year. We use the nth value function to calculate which movie is in the 6th place in terms of amount of movies released. Notice that we do not partition the data and we use the rows between unbounded preceding and unbounded following. That is because all the movies are in just one partition, and we regard all the document set as one group. Let's execute this query on the analytics workbench.
So we execute the query, and you can notice that 2016 is in the 6th place in terms of the amount of movies that have been released compared to the other years.
The next frames mode is the groups mode. The groups mode is useful when the value you sort by contains duplicate values. If that is the case, the groups mode will group together the rows that have the same value, the value in the order by clause, of course. Let's take a look at the following illustration. We can detect 3 groups of movies. The groups are built according to their rating. The first 3 movies have all the rating 7.6. The second group of movies have the rating 6.8. The third group of movies contains only 1 movie, and it has the rating 6.2. So now let's see some examples. If the frame is set to groups between unbounded preceding and current row, and the current row is the row marked in red, then the frame includes all the preceding rows, including the current row, and the row after it. Why? Because the current row is in fact the current group, and it includes all the rows of that particular group. Let's look at another example. Now the frame is set to groups between current row and unbounded following. So if the current row is marked in red, then it will include the current row and therefore the group that shares the same rating down to the last document of the current partition. The window frame syntax also enables you to exclude selected rows from the frame. You can specify exclude current row if you simply like to exclude the current row. You can use exclude group to exclude the current row and all its peer rows that share the same value in the sorting column. Exclude ties excludes all the peer rows but not the current row. Exclude no others means that you don't want to exclude anything, and that's actually the default. The example on the right demonstrates the use of the exclude clause. Here we'd like to include all rows in the frame except the current row, so it is not included. Let's see some more examples. On the left, we specify groups between 1 preceding and 1 following. Since this clause uses the group mode and not the rows mode, the frame for the current row marked in red will include the rows of the current rows group, the rows that share the value 6.8. In addition, the frame includes the preceding group that shares the rating 7.6 and the rows of the following group that shares the rating 6.5. In the example on the right, we can see how the exclude group expression is utilized. The frame of the current row marked in red includes the rows of the preceding group and the rows of the following group, but it doesn't include the rows of the current group, the group of the current row marked in red. Let's explore some more examples. On the examples on the left, we use the groups mode and use the clause between 1 preceding and 1 following. But there is another clause, exclude current row. That is a different clause from the exclude group that we've just saw in the previous slide. Since we use the groups mode, the frame of the current row marked in red includes the preceding group and the following group. But unlike the exclude group clause, we excluded the current row, not group, but row. So the other rows of the current group are included. On the right side, we use the same setting, but here we use the clause exclude ties. That excludes all the rows of the current group except the current row. Notice the tie rows, the rows that have the same values as the current row. Let's see some examples of using the groups mode and the exclude clause. Here, we'd like to display for each movie the average rating of all the strictly better movies in its release year. When we say strictly, we mean that we don't want to include in the average rating calculation the movies that have the same rating as the current row, only the movies that have a higher rating. This is where the groups mode can assist. So our frame clause here is groups between one following and unbounded following, because we want to include all the movies that have higher ratings, but not the same rating. Notice that the order by clause inside the over clause orders the data by the rating in an ascending order. The same query can be written differently using the exclude clause. We ask for the groups between the current row and unbounded following, but exclude the current group with the exclude group clause. These two queries produce the same results. Let's execute the first query using the analytics workbench.
So let's execute the query. The results marked in red all have the same rating vote, so they are regarded as a group. Since we've asked to regard them as a group, they all get the same average value marked in blue. Remember, we are calculating the average rating of movies with higher scores than the current group.
Here's another example of using the groups mode. We'd like to display all the movies and next to each one specify how many movies share the same rating. We need to count movies, so we use the count function. Our frame includes the current group only, but excludes the current row. So we specify groups between current row and current row, which is actually a group, exclude current row. So we include all the rows or all the documents of the same value except the current value. Let's execute it in the analytics workbench.
Notice that the first 5 movies have the rating 10, so each of them has 4 movies with the same rating. There are 4 movies with a rating 8.7, so each of them has 3 movies with the same rating. That shows how the exclude clause can be very useful.
Let's see another example. We'd like to display for each movie the immediate better movie rating. Again, we need to use the groups mode because if we don't, the following movie might have the same rating. Then we specify the frame boundaries, which are between one following and one following. We just need the following group. From that group, we take the first value, but it can be also the last value since all the ratings are the same for that group. So this is why we use the function first value. Let's execute this on the analytics workbench.
Notice that the first value function returns for the first 2 rows the rating of the next group, which is 2. We also see on lines 3 and 4 the next group value, which is 2.5, and so on.
The third frame mode is the range mode. The range mode simply instructs the database to work on a specific range of values. Instead of rows or groups, the range mode refers to the ordering field itself. That is the field used by the order by clause of the window function. On the example here, we've selected the range between 0.8 preceding and 0.5 following. So if our current row is marked in red, then the range includes the rating inside that range. And you can see it here in the slide. Here's another example on the left. We specify range between 0.8 preceding and current row. And so the range for the current row marked in red holds all the rows within the range, including the following rows that share the same rating as the current row. The example on the right uses the same range, but here we've added the exclude current row clause. That will exclude the current row from the frame. Now let's see some queries. In this query, we'd like to count how many movies have a better rating by 0.8 or less for each movie. So we use the count function and we specify range between current row and 0.8 following. But since we want to count only the movies that are better than the current movie, we need to exclude movies that share the same rating as the current movie. We can do that by specifying the exclude group clause. Let's execute this query using the analytics workbench.
For the first two movies in the list, we can see that there are 0 movies that have a rating of 0.8 or less. That is because these movies have the rating of 1 and the next movies have the rating of 2. For the next two movies, we can see that there are 2 movies with a higher rating by 0.8. Here they are marked in blue, and so on and so forth.
Let's see another example. Here we'd like to count for each movie the number of movies besides the current movie that have a rating that is higher by up to 0.5 or lower by up to 0.5. So here we use the clause range between 0.5 preceding and 0.5 following to include these movies in the count function. But we exclude the current row or the current movie from the count calculation. Let's execute this query using the analytics workbench.
To check the result, I've picked the movie Britney Ever After. It shows that there are 2 movies that have a rating higher or lower by 0.5 when compared to the rating of the Britney movie, which is 2.8. These 2 movies are marked in blue. For the movie The Summoning, there are 3 movies that have a rating higher or lower by 0.5 compared to the rating of The Summoning movie, which is 3.2. These 3 movies are marked in blue.
With that, we've came to the end of this session. So what have we learned? We've explained what window functions are used for. They can help you to fetch aggregated information alongside non-aggregated information. Couchbase processes window functions after the data is filtered and aggregated and before it's projected to the client. Window functions produce a much better performance than correlated queries. Window functions are supported by both the query engine and the analytics engine. With window functions, you can use all the aggregation functions you are familiar with, like sum, count, average, etc., alongside special window functions, such as row number, first value, NTILE, etc. Window functions can divide your data into partitions, and they can be ordered by a selected field. We've also explored different window frames, which are selected rows within the current partition that are moving with the current row. We've learned that frames can be created with the rows mode, or the groups mode, or the range mode. You can also exclude specific rows or groups from the frame if you're using the exclude clause. For more information, check out Couchbase's documentation. And that's all. My name is Lior King, and I hope you've enjoyed this session. If you have some questions, please submit them in the chat window, and I'll be happy to answer them. Thank you very much.